We're going to do a review lesson today from Algebra 1 on absolute value equations. And if you remember from Algebra 1, absolute value of any number is the distance that number is from 0 on the number line. We always talk about absolute value being non-negative, so it's either going to be 0 or a positive number. And so if we look at the absolute value of 4, we have 0 on a number line and we have 4. The absolute value of 4 is 4 because it is 1, 2, 3, 4 away from 0 on the number line. The absolute value of negative 4 is also 4 because it is 1, 2, 3, again, 4 units away from 0 on the number line. Let's look at equations. Definition of an absolute value equation, we're going to let a, b, and c be constants, and c is greater than 0. And we can rewrite this, we're going to solve this by rewriting in two equations. We're going to take what's inside the absolute value, ax plus b, and we're going to set it equal to c and solve. And we're going to take ax plus b and set it equal to the opposite of c and then solve for x. And we'll see why on the next page. So here we're getting the steps we're going to do to solve. First we're going to isolate. And in this problem we already have the absolute value isolated on one side. So now we can write two equivalent equations without the absolute value signs. So we're going to have x minus 4 be 12, and we're going to have x minus 4 be negative 12. And the reason why we do that, because if you think about it, you want whatever's over here, the distance that is from 0 on a number line has to be 12. Well, we saw on the previous slide that if the distance has to be 12, that means what's inside here could be 12, or it could actually be negative 12, because both of those have a distance from 0 of 12. And so that's why we can set it equal to both of those two and solve for x, and why we have two possibilities. So the one on the left, x is 16. The one on the right, x is negative 8. And we can graph that. And since it's just x equals, we're just going to do a closed circle at negative 8 and a closed circle at 16. And that's how we solve in general. So let's try two more problems. In the problem on the left and the right, we have to isolate and get the absolute value by itself. So in this case, we're going to subtract 5 first from both sides, and then we're going to divide by 2. And now we have the absolute value isolated. So from this point, we can write our two equations, and we can get x is equal to 8 and x is equal to negative 12. And it's always a good idea to go back and plug them in and make sure both work. So we plug in 8, 2 times 10, absolute value of 10 is 10, so 20 plus 5 is 25, that works. Plug in negative 12, we get negative 10 inside the absolute value, but the distance that is from 0 is 10 on the number line, so we end up with the same thing, we end up with 25. So both of those answers work. Okay, problem on the right. Subtract 15 from both sides. We have the absolute value of x minus 1 is equal to negative 7. Now, if you don't notice anything interesting here, and you go on and you say x minus 1 equals negative 7, and x minus 1 equals positive 7. You're going to solve, and you're going to get two answers. But look what happens when you plug them back in. If I plug in negative 6, I get the absolute value of negative 7, which is 7 plus 15, which is 22, which is not 8 up here. So that doesn't work. When I plug in 8, I get the absolute value of 7, which is 7. I get 22 again, which is not 8, so that doesn't work. But if you did all this work, you did too much work. If you look at the first thing we did here, we subtracted 15. You notice there is a negative on the right side. Absolute value cannot be negative. So from this point right here, we could have stopped, and we could have said there is no solution to this problem. And you could write no solution. You can write empty set like that. You can write empty set with the curvy brackets with nothing in the middle. So we have an empty set. We have a no solution problem. If you forget to check that and you go through and do the math and set the two equations, remember to double check your answers because that's where you're going to see the extraneous. And so we call those solutions extraneous that look like they work. They're apparent solutions, but they're not correct because they don't satisfy the original equation. They don't satisfy the one that's typed up in the book or written up here on the board. So let's solve this one. We have the absolute value isolated, so we say 2y plus 5 is equal to 3y, and 2y plus 5 is equal to negative 3y. And if you notice, there's a variable on the right, and this is a lot of times where an extraneous solution is introduced. So we solve, and we get 5 is equal to y, and we solve over here, and we get 5 is equal, or y is equal to negative 1. And so let's double check both of them. So I'm going to say 2 times 5 plus 5, is that equal to 3 times 5? And so I get 15 in here. Is the absolute value of 15 15? Yes, so that one works. Let's check the other one. Negative 1. So I get the absolute value of 3. Is the absolute value of 3 negative 3? Is the absolute value ever negative? No. So we label this answer as extraneous. And we want you to show that you tried both, you wrote out both equations and you checked both answers. Okay, you can't just write down and show this without ever showing any of this work here.